No.
So I throw him up, and he's going up, but every instant, he's going up less and less until at his peak, he stops.
Ada, this is critical.
Exactly. We reach the critical point where going up less and less is no longer going up, but going down. And likewise, I've reached the critical point in our friendship where I'm gonna like you about as much as I can.
Well, I don't want to peak too soon.
But on the plus side, my frustration with you is beginning to trough.
Oh, perhaps your frustration with me will trough. At the same time, your liking for me peaks, making a kind of half peak, half trough monstrosity.
That joke was just sad.
Yes, a saddle.
That's not even what I said.
A point of inflection.
I swear, sometimes your words are gaga nonsense.
I'm gonna let you finish, but if you follow the graph of our friendship...
Sit down, Kanye.
Oh my goodness.
I wanna know whatever increase or decrease. Just take the first derivative and say with me. Positive or negative means slope is up or down. And zero tells you where a critical point can be found. Oh, zero, zero, a critical point, critical point. Oh, zero, zero, a critical point, a critical point. Do it once, do it twice, and you will see where my glass contains. Plus a smile, minus frown, and then you'll know where my glass contains.
Concave up or concave down, down, down.
Second derivative, oh, inflection point. Second derivative, oh, inflection point.
I can tell you if you're addled, it's a saddle, curly trouble, zero, double, critical point intersection with my point inflection. Just like a change in entropino, going back, no way to turn around, it's critical, critical. Check this curve,
Do it
analytical.
once, do it twice, and you will see where my glass contains.
Second derivative will tell you.
Plus a smile, minus frown, and then you'll know where my glass contains.
Concave up or concave down, down, down.
Second derivative, oh, inflection point. Second derivative, oh, inflection point. Mr. Angie,
Points of inflection! Big Isaac!
good
Big
times.
Isaac! Big Isaac! Oh, little Isaac. Big Isaac? What about us? I thought we were best friends. Oh, little Isaac, I still care about you.
Do you two need a minute?
But the word best implies that you like that friend above all the others.
I'm gonna give you two a minute.
Apologies, little Isaac. But you and I, our friendship has already reached a global maximum. While Ada and I, our friendship is only approaching a local maximum, followed by a local minimum, then up and up and up to BFFs. We've reached global maximum? Yes, just like the one you reached when I tossed you up. Profit! All right. Oh, look. The equation for your height to respect time is here. The derivative shows me how fast you're moving at every instant, so I find the instant where you have stopped completely, and that appears to be your maximum. The instant before, you're still going up. The instant after, going down. Absolute maximum at your peak. QED. Schnopp. Do you say schnopp now because Leibniz says schnopp? I was saying schnopp long before Leibniz was saying schnopp.
Stop copying me, schnopp.
Germans! What about my trough? You don't have a trough? You're not a horse? What about my minimum point? I want a trough! Your minimum point is when you hit the floor. I mean, when I catch you, as long as it's lower than when I let you go. What about saddles? No saddle either. You are not a horse. I think I can explain this better, but I'll need to obtain some assistance. Ada. Ada? Ada! Oh.
What's up?
We have an idea for a group project.
Okay, how many people do the two of you need?
3 stoic audience volunteers should do it.
Can I get 3 stoic audience volunteers? Starting with this individual right here. This guy right here. I need 2 more stoic audience volunteers. There's one. And you. Very nice. You'll line up right here in the center. What was your name? Sana and Diana. And Daniel, thank you very much.
Now we are going to sing a little song. You will be saddle, you will be peak, and you will be trough. Now, when I say the word saddle, you are going to bring that sign up and bring it back down really fast.
Okay.
Wow, you knew exactly what I was asking for. Saddle. Nice. Let's try peak. Good. Trough. Hey, they got it. Will you sing along, Ada?
I'll try, but I'm a little hoarse. High five. Oh, Isaac, right there, right there. You left me hanging.
He's waiting for the main event. For maxima and minima, just take derivativima. Happiness, now you assess the 0, 0, 0, 0. Don't forget you must inspect the endpoints as they are suspect. Find the values of our functions, look for highs and lows.
Local maxima.
Are on an interval.
Local minima.
Are on an interval.
Global maxima.
Are on an interval.
Global minima.
Are on an interval. Turbo, turbo, turbo. Saddle, peak and trough and saddle, peak and trough and saddle, peak and trough and peak and trough and peak and trough and saddle, peak and trough and saddle, peak and trough and saddle, saddle, peak and trough and peak and trough. Maxima and minima are also called the extra. Sometimes they can be absolute, as long as there's no greater or lesser. Relative implies a region that the extra are in. Don't confuse a saddle point. Don't confuse a saddle point. Don't confuse a saddle point with an extra Do we need more extra
Just tell me when you're done.
Oh, I was just vamping until you were ready.
Saddle, peak and trough and saddle, peak and trough and saddle, peak and trough and peak and trough and peak and trough and saddle, peak and trough and saddle, peak and trough and saddle, saddle, peak and trough and trough.
Yes! Wonderful. Now we are just going to freestyle dance. Just shake those signs, everyone. Da, 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 da,
Wait, no, hold still. Hold still, I want to see this. Yes, I do see this everywhere in the real world. Bridges, buildings, roller coasters.
Wait, why did you stop? Keep shaking your signs, everyone.
No, hold still. I want everybody to look at this. Yes, even the abstract things are starting to make more sense now. Like orbital velocities and rates of growth and even elements of designing video games. They're all based on this simple thing right here.
Shake, shake, shake your extra mind.
Isaac! We're done. Thank you so much. You can wait here for just a moment. Thank you so much. Let's hear a round of applause for our stoic audience volunteers. And to thank you for your time.
These things?
Yes. To thank you. It's the all-star cast recording of the soundtrack of Calculus the Musical. Another round of applause as they find their seats. Thank you so much.
Ada, we were having fun. Whoa, frustration.
Isaac, I am really trying to help us both out here. I I am trying to move us both forward with this whole calculus thing, but you just want to play around all the time with your dance parties and your snacks and your creepy action figures. Seriously, what is my subconscious trying to do to me? Why couldn't I have had a dream about somebody awesome, like Marie Curie? Or, I don't know, somebody not annoying and actually dreamy, like L'Hopital? Yeah, that's a mathematician I'd like to see dancing around my head at night, but you, Cookie Man, are my antiderivative.
What did you call me?
My antiderivative, pastry head.
What did you call me?
My antiderivative, biscuit eater.
Oh, antiderivative. That sounds integral.
Actually, yes. If a derivative is taking a step forward, the antiderivative is taking a step back.
So you're saying it's like we take 2 steps forward and 2 steps back.
Pretty much.
2 steps forward and 2 steps back. Antiderivatives reverse a process back, so let's see. This addition makes the puzzle come back. Antiderivatives reverse a process back.
That must be a Paula Abdul song. How do you know who Paula Abdul is? I don't think they even know who Paula Abdul is.
Antiderivatives, they are too legitimate, too quit it. Too legitimate, too quit it.
Thanks, Einstein equals MC Hammer squared. Dumb.
No, Ada, antiderivatives, they have my mind all fired up. Like a red, hot, chili pepper.
Dad rock.
Area under curve that flex equal to the antiderivative of f of x dx. It is fundamental geometry and analysis time. The integral from A to B, antiderivative, take the value at B sub, track the value at A, integral from A to B, antiderivative, take the value at B sub, track the value at A.
That's the big deal.
Yes?
That's amazing.
Is it?
It's the fundamental theorem of calculus.
It's the fundamental theorem of calculus. It's the fundamental theorem of calculus. It's the fundamental theorem of calculus.
I think you have to tell everyone how it works.
Well, easy. It works because it is mathematically true.
Yes, but why is it mathematically true?
Because math.
But what?
Because math.
But how do we know that? Triangles!
May I wear the costume this time?
Go for it.
Yes!
It all started 2,000 years before Isaac Newton in ancient Greece.
Hi, friends. Archimedes here. I'm just taking a break from the bathhouse to let you know that I've developed a method that has the power to find the area of any shape. No, I hear what they're saying. They're saying, but Archimedes, what if this shape has a curve? How am I supposed to find the area under a curve?
We don't know.
Well, friends, the secret is in finding the area of a triangle. We simply multiply base times height, take half the product. A equals 1/2 base times height. There you go. So what you're gonna do is you're gonna draw yourself a point on that curve, and then draw yourself a triangle and write down its area. But I'm not stopping there. I'm gonna throw in another triangle using the first triangle as its base. And then another triangle, and 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 another triangle. Can you show me another triangle? How about another triangle? What about another triangle? Yes, and another triangle, and another triangle, and another triangle, and another triangle, and another
Time to clean this method up a little
triangle.
bit. Fast forward to Germany, 200 years after Isaac Newton. Enter G.F. Bernard Riemann, the original home slice. As it's my turn to wear that costume.
Oh, I like the toga. Toga, toga.
Right. Before you stepped out of your bathtub time machine, you invented music, right, Archimedes?
That was Pythagoras. That would be like me confusing you with David Hasselhoff.
That you're obviously familiar with this work, so make for some beats, yeah?
Ugh, Germans.
GFB Riemann. No gimmicks. To find the whole area under the curve, under the curve, under the curve.
A, B, A, B.
To find the whole area under the curve, under the curve, under the curve.
A, B, A, B.
Interval A to B. F of X. Stay with me. F of X, 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 F of X. No. I'm a curve at all angles. I'm using rectangles to find areas, so I use slices. One to angle. If you want slices, this is what I'll tell ya. Each little width is B minus A over N, cause width is changing on the X. It's delta X and height. F of X, the back from the middle or the right or left, cause you're evaluating from the eye of the sense that you are calculating. The area is from multiplication of the base and the height. Give me some adulation. You know you got sigma notation when your slices add up to a big summation, so the big CE won't disagree. Let me decree Archimedes. He had the same idea in ancient Greece, but it feels exhausting without Riemann. Hanover kids, some of the bits more cunning and wits and Brechtian skit to get on it. It's all working now, you don't show that. I just set up my summation time to sum it.
Yeah, this looks like a job for Riemann.
Add it up from A to B, and the more slices that you see can increase your accuracy.
Yeah, this looks like a job for Riemann.
Add it up from A to B, and the more slices that you see can increase your accuracy. Little slices make area nicest. The smallest of sizes will be the precisest. Infinitesimal bits will entice us till someone comes along with a vision and yells, visionary vision of area. To start the transformation, summation is changing with limits, and it's getting greater so vast that it's a fact that I'm without those little slices I'll last to count them. Such a catastrophe, because there could be enough time to count to infinity. But step back. There's no width of making truly the notion to letter D for delta, a differential trendsetter. They're missing on notation, slimmer is better. It's the best thing, the S thing suggesting, divesting X of the sub I am stressing.
Anti-derivative.
When I mentioned integral fx dx, who made sense and since from A to B, and Newton, not him.
No, not me. No, this looks like a job for Riemann.
Add it up from A to B, and the more slices that you see can increase your accuracy.
No, this looks like a job for Riemann.
Add it up from A to B, and the more more slices that you see can increase your accuracy.
Yeah, this looks like a Jumperima!
Integral from A to B and slice to infinity for your perfect accuracy.
Teacher of math! You go, girl!
Isaac, this is awesome. I am finally starting to see that the world has an order to it. I mean, I used to think calculus didn't have anything to do with anything, but think of all the relationships.
Relationships?
I can see so many natural, physical relationships.
Physical relationships?
The way the bodies interact and react to the stresses of the world around them.
Friend, I should mention I have a vow of celibacy.
It's so awesome to understand that the integral of force, the derivative of force's work, and the integral, the force, and any object, no matter how massive or how fast it's traveling, always falls to Earth with the same acceleration.
Oh, yes, those relationships.
Position is the place you are at any given time you see.
I am here.
The instantaneous rate of change of that is the velocity,
Moving over here.
which is direction and the speed, 2 parts of information.
1, 2.
The instantaneous rate of change is called acceleration.
Vroom, vroom.
The total distance traveled is by no means an atrocity. The integral of absolute value of the velocity. Another point of interest, no, the integral of force is work. Acceleration's rate of change is surge or lurch or jolt or jerk.
Acceleration's rate of change is surge or lurch or jolt or jerk. Acceleration's rate of change is surge or lurch or jolt or jerk. Acceleration's rate of change is surge or lurch or jolt or jerk.
Displacement is how far you are from your initial starting spot.
What's over there?
Remembering the average value of a function is a lot.
That's a lot.
1 over b minus a times the value of the integral from a to b of f of x dx upon an interval.
1 over b minus a times the value of the integral from a to b of f of x dx upon an interval.
Secret handshake.
Secret handshake. Ada, your brain is as luminous as quicksilver. I shall go publish.
Yes!
And the world shall know that I, Isaac Newton, invented calculus and physics when no one else could.
You're kidding though, right?
No.
I mean, you realize there were tons of other people who allowed you to succeed.
Well, I never met any of them.
Are you being serious? We just saw Gottfried Leibniz
Germans.
and Robert Hooke
Robert Hooke.
and Archimedes
Toga,
and
toga.
Riemann
Hat drop.
and tons of others who didn't even show up in this dream.